All right, let's talk for a little bit. So we've now spent like an extra day on the minimization problems with the duals and all that kind of stuff. Do we feel like we have that under control now?
Yeah.
Okay. I personally agree. I think that's kind of a mess. Okay. On the other hand, it seems like a very necessary mess. I mean, once you knew that there was such a thing as standard max problems and standard min problems, they both seem perfectly reasonable. They sound like real problems that in real businesses you would need to solve. Let me go ahead and start the projector, the show here. And so, you guys don't know if there's like some kind of clicker that I could be moving it forward while I'm... Nah, I don't think it does it.
Have to get one.
Yeah, you have to get one separately. Okay. Alright, so and both of them seem like perfectly reasonable types of problems that would occur in real business situations or real science situations or whatever. And so, I mean, the fact that the minimum ones require that weird duality trick, well, that's kind of odd, but once you know it has to be done, and that flips it over into its dual problem, which is the max problem, it's just not that big of a deal. Today, we're going to take a look at there's actually two more types of non-standard problems that we have to deal with. They don't fit this idea of a standard max or a standard min problem. We'll only do one of the two today. The other one is the ones that require what are called artificial variables. Now, way back, gosh, it feels like forever ago when we were learning the simplex method, I mean it was only like a week and a half ago, we were learning about the standard maximum form, where we are trying to make some objective variable be maximized, and we had a whole bunch of constraints that were in the form of, you got stuff, and you can only use so much of it. You got other stuff, and you can only use it. In other words, they all had less than or equal as part of the constraints. We've only got so much flour, so much sugar, and so much frosting. How many cakes, how many cupcakes, and how many donuts should we make? Or there was those standard min problems that work the other way around, where there's some objective function we are trying to minimize, like costs would be a common one. And we have these constraints that are in the form of, but we have to do at least this much. I mean, usually you could minimize the amount of costs at your factory by just not making any cars and any trucks and any Jeeps. But that isn't necessarily the best solution, right? Maybe you have contracts, you have to build at least this many. Okay? The number of cars plus the number of Jeeps plus the number of trucks has to be at least this many. Or you have to have a certain number of hours. You have a contract with the union that you have to use at least 100,000 man-hours this month. Well, okay, there's this many man-hours per car, plus this many man-hours per Jeep, plus this many man-hours per truck. Has to be at least this much. Okay, there are constraints that way. Because you might have thought that the reducing cost of the thing would be just make none, but that's not in the feasible solutions. And these are both perfectly practical things that happen in the real world, that is part of the whole business of logistics and business management and so on. And in some ways, the two types of problems we've seen before are so useful, but in other ways, they're perhaps a bit unrealistic. And unrealistic is maybe not a great choice of words. I think your book used that word at one point. Maybe general would be a better choice of words. Because here's the deal. I'm not liking the fact that all my constraints have to be one or the other. They have to either all be less thans or all greater thans. It seems perfectly reasonable that there could be problems that have both less than symbols and greater than symbols in it. You can only use as much flour as you have, and you have to make at least this many cakes. I mean, that seems like a much more general type of problem, right? Okay. Because that seems, I mean, and now thinking back to our days when we were doing this as linear programming on a piece of graph paper, or on Desmos or something, I can picture how this would work, right? I mean, I'm just making myself a feasible area with these inequalities, and then I'm going to use the corners. And the fact that some of them were less thans and some were greater thans, who gave a damn? In fact, back in chapter 3, when we did some of those on graph paper or on Desmos or whatever, you did it, and we didn't even give it a thought. Right? Some of the inequalities went this way and some went this way, and we didn't even think about it. Okay, it's a perfectly reasonable thing to want. And we're going to be working our way through an example that is used in your book, and pick it apart and see how this is a so-called non-standard problem. Okay, so, I love this one because it's so stupid. The person who wrote this book clearly has no concept of farming. I grew up on a farm. We didn't grow cabbages and, well, we grew cabbages and potatoes like in the garden, but not like hundreds of acres of cabbages and stuff like that. But anyway, it's like weird how the guy has like no sense of what the costs are in LF. Okay. It's all just numbers. Here's our problem. A farmer has 100 acres available of land on which he wants to plant a mixture of 3 different vegetables, potatoes, cabbages, and corn. It costs him $400 to produce an acre of potatoes, $160 to produce an acre of corn, and $280 to produce an acre of cabbage. And that's his costs, seed and pesticides and stuff like that. He has $20,000 to spend. His expenses cannot come to more than $20,000 or he can't write the check, right? To satisfy orders from his regular buyers, the farmer must plant at least 60 acres of the 3 crops. In other words, he has some contract already that he has to provide, a wholesaler or something, at least this much stuff. That seems a little unrealistic. It seems like they would have a contract of it has to be at least this much corn, and at least this much potatoes, and at least this much cabbage, but we work with what we got, okay? Whatever. He needs at least 60 acres of vegetables in order to. But it might be that to cover his costs, he can't fill the other 40 acres. Right? He doesn't have any money to spend on corn and pesticides and stuff like that. He makes a profit of $120 per acre of potatoes, $40 per acre of corn, and $60 per acre of cabbage. I tell you, an acre of cabbage is a hell of a lot of cabbage. You guys know how big an acre is? Yeah, like, roughly a football field. A lot of cabbage.
I live on potatoes.
You live,
He's making bank on potatoes.
He's making big, well frankly, I don't know. I mean, none of these are all that big in numbers. All those things are a lot of work. Maybe corn, if you came through.
That doesn't seem like.
It doesn't make anywhere near enough money.
No, that doesn't make enough money, and it's like you can't just satisfy orders by planting a total of 60.
Yeah,
acres.
exactly. It's not a very realistic
works.
problem in this. But the idea that there is a mix of constraints makes sense to me. Alright, so how many acres of each crop should he plant to maximize his profits? Now, I capitalized that sentence right there because your first glance might say this is a standard max problem. And you would be, let's pick this thing out. So what are the variables in this problem?
Potatoes, corn, cabbage.
Acres of potatoes, acres of corn, acres of cabbage. Oh, what do you think? I think I made a slide on that. Whoa, there we go. There we go. Acres of corn, acres of potatoes, and acres of cabbage. Yep, okay. Half the battle is setting these problems up. Right? It's only half the battle. But it is like half the battle, right? Sometimes you look at these problems like, I don't even know what they're asking. The skill of picking these things apart is a good thing that you didn't know how to do before this chapter. So we're happy. Okay, so what are the constraints here? What are the, when we make our problem, maximize this, subject to, what are the constraints of this problem? What's one of the things he's got that's limiting what he can do?
100 acres.
Yeah, good answer. X1 plus X2 plus 3 has got to be less than or equal to 100, right? He can't plant on his neighbor's land. Okay?
All the prices have to be, I guess it has to be at least 20,000. Is that what it means?
Nope. He only has $20,000 to spend. Yep. So however much it costs per acre of corn plus however much it costs per acre of potatoes plus however much per acre of cabbage only adds up to only spends $20,000. I think those are the only. One more constraint. What?
I said at least 60.
Yep, and X1 plus X2 plus X3 has to be at least 60. Because he has to satisfy his contracts or whatever, he has to have at least 60 acres. Okay. In a real world problem, there'd be more than this going on probably. Because there's all kinds, every industry, every sector of the economy is complicated in other ways. For example, a real problem like this would probably also include things like he probably has options where he could lease land from somebody else. If he's making good money on those taters, it could make sense for him to lease land and plant more taters. Or it could make sense to, there could be more constraints in here about cost of borrowing. If it turns out he could make more money if he had another $1,000 to spend to plant more potatoes, because he makes good bank on those potatoes, it could be that it makes sense to go borrow money on the plant, right? A real problem would have even more and more constraints. Okay? We're just not going there because how many times do you feel like pivoting this thing? Right?
Thank God for spreadsheets.
Yes, exactly. God, for spreadsheets, no kidding. So the constraints we picked out were that the total acres that he can plant is going to be less than or equal to 100. We're not going to play the game of what about leasing other people's land or anything like that. And, okay, I wanted to show in this example here, they said, okay, $400 per acre of corn or whichever, $150 per acre of potatoes, and $280 per each acre of cabbages, let's say, is less than $280,000. Turns out you can just divide through by a number to keep the number smaller. And so they divided through by 40, because that was just a common multiple of all these things. So they divided through by 40, and got 10 plus 4 plus 7, less than 500, just to keep the number smaller. There's absolutely no advantage to that. I mean, on a spreadsheet. It's just they kept the number smaller, thinking you might be doing this on paper. Okay? Because it doesn't change the problem at all. Any value of x1, x2, and x3 that satisfies this just as well.
So that's perfectly acceptable.
That is perfectly okay. Just keeping the numbers a little smaller that way. There have been a handful of times I've been making these PowerPoints where I've wished I would do that, just because they start getting kind of like the numbers in that bottom row start getting kind of big. But I didn't do it. So. All right. Also, we have to plant at least 60 acres. x1 plus x2 plus 3 has to be at least 60. All right. I think we got the constraints. All right. Now in this problem, again, remember, setting up the problem is like half the battle. What is the objective function? What are we maximizing or minimizing? What? Well, first off, just in words. What is it we're maximizing or minimizing? He wants profits to be maximized. He's formulated the problem in terms of profits. There could have been reasons why he wanted to do this in terms of minimizing the amount of costs. Or he might have done it, like he has different goals. Like maybe he's trying to minimize the amount of pesticides he used, and then we'd have different information in the problem, okay? But he's just maximizing costs here. I'm sorry, maximizing profits here. So he goes through here. And then came up with the cost, the profit was equal to all this stuff. Or you pull everything over to the side of Z. And you get this. Hey, brief connection here. Have any of you gone to see the movie that's out right now, Christopher Robin?
No.
Did you see it? Did you notice what he's doing? What is Christopher Robin? Christopher Robin, you know what the movie is, right? Christopher Robin, the grown-up little boy.
Yeah.
What?
He's trying to find a way to get more money without firing people.
Yeah. His job was doing this stuff. He was trying to find a way to minimize the weight and maximize the profit on suitcases. He worked at a suitcase. Christopher Robin grows up to be the efficiency manager at a suitcase factory. And he was trying to minimize the weight of the suitcases and maximize it. And if he couldn't get it under a certain amount, he had to fire somebody. Yeah, and I was like, I took my kids to see a matinee of Christopher Robin the other day, and they're all Googling about Tigger and Pooh, who are in the movie.
I didn't think they would have something that sad.
The whole movie was so sad.
And you're sitting in
And I'm like going, they're doing simplex methods.
How did you feel whenever they solved it by just turning the graph
I didn't
upside
understand
down?
that at all. I was like, what? He turned the graph upside down and he said, there's our solution. They were like, he's a genius. Anyway, it's not a great movie. It's not a great movie. Wait for it on Netflix. Anyway, my kids are obsessed with Pooh, so anything Pooh we had to go see. Alright. Alright, so the example that we have then, we have now created a problem. We are maximizing this. That loop sounds like a standard maximization problem. And look, we can only use this much land, and we can only spend this much money. Remember, this came from money. We just divided through by 40. And we got to, oh crap, we've got one that goes the other way. This isn't a standard maximum problem, and nor is it a standard minimum problem. Remember, if this had all been the other way, if it had all been this way, we could have rewritten this thing to be a minimization problem.
Wouldn't you just make it a negative slot variable then?
Oh, we're going to find out why that's not going to work. Okay, but here's the deal. You're kind of on the right track. You're almost there.
Okay, because I'm looking at
Yeah, we're heading that general direction here. All right, so now we're going to convert those inequalities into equations. So, all right, the first one. We know how to do this. x1 plus x2 plus x3 plus some slack is then equal to 100. Odds are, if we're maximizing profit, we're going to be actually planting the whole 100 acres. But it might not be. For example, maybe we make so much money on potatoes, spend all of our money on potato seed, and if we can't plant the whole 100 acres, so be it.
Okay, I just have a question that doesn't make sense in my head.
Yeah.
If like, let's say, it says that making 1 acre of potatoes is like $400, but he doesn't sell them, he only sells them for like $120.
No.
Will he ever like?
No,
is
no,
that-
it's that's the profit. It
Oh.
cost him 100 to 400. The profit is going to be whatever that, and he makes 160. So
okay.
it's the revenue is 560.
Okay, so it's
yeah,
like-
yeah.
It's,
He sells
he's
it
making-
for
he's
560.
making 120
Yeah.
on top of what he's
Yes,
okay,
exactly.
so I took that as he was just selling it for 120. I go, you're not
Okay.
gonna make any.
I can't believe I hadn't noticed this, by the way. We were just talking about Christopher Robin and Winnie the Pooh. Notice he's got 100 acres.
Yeah, that's where you were
Boom,
going.
boom. I didn't even notice that. That's cool. All right, because he lives in the 100-acre wood. All right. All right, that one was easy. We know how to do that. And for that matter, we know how to do it with regard to the money one. All right, so if the money has to be less than, well, 20,000, but 500. Well, it's just plus some slack. Okay, we know how to do that, but we don't really have that strategy over here with this one. Because there's no slack. It isn't like the amount of acres we have of corn plus the acres of potatoes plus the acres of cabbage plus some extra adds up to 60. It's kind of the other way around. It's kind of how much corn we got plus how much potatoes we have plus how much cabbage we have. It's going to be running a little over 60. Possibly a lot over 60. Well, our strategy here is to introduce what we call it S3 here, in this case. See how this makes the same thing? X1 plus X2 plus X3 minus some extra will put us back down to 60. Like if we planted at 75, then we're talking X1 plus X2 plus X3 minus 15 will put us back on 60. And we have a slightly different word for this. Instead of calling this a slack variable, or I liked what MJ was saying about them being like a negative slack variable, but here's the deal. We need to call this something else. We're going to call it a surplus variable. This is the extra that we use. Now, MJ said, why not just let it be a slack variable that's negative? Here's the deal. That's going to cause problems. In fact, I think there's a couple slides where they explain that. If not, there definitely is like a paragraph in the book where they explain it. The problem is then we're going to have, one of the constraints, remember, when we're solving these kind of problems is all the variables end up being positive. X1 is going to end up being positive, X2 is positive, X3 is positive. All the slack and surplus variables have to be positive. That is buried in the derivation of how all this works. Because remember, when you do things like divide by the negatives, you flip signs and stuff like that. Flip the directions of the inequalities, and that would make a huge mess of this problem, right? So we got to do it so we keep it so that all the variables, including this surplus variable, it has to be a positive number. Okay? If we could play the game of negative slack, we could do that. Well, we would have problems of keeping track of all the signs then in which directions the inequalities are going. Better to keep everything positive and not have to worry about that. Okay, so I'm not going to spend huge amounts of time thinking about the idea of surplus variable, other than, oh, it kind of makes sense. It's like the opposite of a slack variable. It's what we're going over. All right. Okay, so once we have that thing, we're going to have a modified version of our strategy of how to make this thing work. Because we're going to put together our tableau. And you know how to do these pretty well now. I don't think I have to walk through this whole story of how all this worked to get it put together like this. And you do have this negative one over here. And I can't remember if it was on a quiz or one of the exit tickets or whatever, but somebody wrote something about you can't have any negative signs in the tableau. Now, there can be negative signs in the tableau. That can happen places. But that does, in this case, mean something. Okay? In fact, let's just make sure we're clear here. Anytime I was doing some row operations here, if I had it turned out my row operation was this minus, or this plus this, well, that would make this one have a negative value. That in and of itself is not so scary. But here's the deal. Because these guys are, well, wait, let's actually read a value off the tableau. If this is a tableau, MJ, this is your first course you've had with me. So you are probably about to be shocked to learn that I lie. I lie a lot. When I teach, I lie like crazy.
Yeah, you do that in pre-cal.
I do. Something I told you wasn't so much a lie is that we hadn't yet come across the exceptions to it yet. And one of the things I've told you so far that was a lie, not so much a lie, an oversimplification, I said you can always read an answer off the tableau. As long as you have done this right, you can always read an answer off the tableau. That is true for the standard min and the standard max. The tableaus for the non-standard ones, we will eventually be able to read an answer off of them. But, as you're about to see, the answers aren't always feasible yet. I mean, like, let's pick this one. Alright, if we were just going to pick an answer off of here, we would first find the basic variables. They're easy to find, we're good at that now. Which would mean, these are the non-basic variables. Right? If they're not the basic ones, then they're the non-basic ones. Alright? If they're non-basic, they're equal to 0. Right? So, just picking off of here, if x1 and x2 are non-basic, they're all equal to 0, doesn't that make you say, wait a minute, you were told x1 plus x2 plus x3 had to be at least 60. And we're just adding 0 plus 0 plus 0 is greater than 60. We got a problem. That should make you a little bit suspicious here. And remember, we said that all the variables have to be non-negative. And, okay, well, we can just pick variables off here. Okay, the basic variables. 1 times s1 is 100, so s1 is 100. 1 times s2 is 500, so s2 is 500. Negative 1 times s3 is 60, so s3 is negative 60. We also have a negative surplus variable. Well, that's not right either. So here's the deal. It's not that there isn't a solution on here, it's that the solution isn't feasible. With the non-standard problems, we first have to do stuff to the tableau to even get into the realm of feasible solutions. And then we might have to do more pivots and simplex stuff to get it to the optimal solution.
So do we just keep pivoting?
It's going to be pivoting. It's a modified strategy of how to get where the pivot is. Okay? So, alright, what are we going to do here? Let me first quote you something from your book. Every now and then it's useful to know that there's a book and it says things. Again, I personally think this chapter 4 is just really, really dense. Personally, I think that chapter 4, he could have spent a few more pages talking about this. Right? Every one of these things, like he spends like 3 pages doing an example, and then like 1 paragraph explaining how it worked. You know, that 1 paragraph just explained that whole thing? Holy crap. I think it's a little bit dense. So let's be clear about finding the key sentences in your book. And on page 171, there's sort of a key sentence. It says, when there's a negative value of a variable in your solution, row operations are used to transform the matrix until a solution is found in which all the variables are non-negative. Okay? So our first strategy here is going to be doing pivots and stuff like that to at least get out of the business of things being negative. The solution being negative. That means there isn't any negatives up there on the tableau. It means that they could be, for example, in the non-basic variables. Feel free to have as many damn negative signs over here as you want in the non-basic variables. They don't hurt anything. The result of those variables is 0 anyway. Alright. Now, don't forget, okay, if the idea is to make this whole thing non-negative, and you could always multiply or divide by a number on a row, I get it that it's really tempting to just multiply this row by -1. That seems like that would solve this problem. Then this thing is done. I mean, oh crap, but that would make this thing a negative number. That doesn't solve anything. Nope, we gotta play the game of pivots. Alright. What is going to be our pivot here? Okay, now I'm going to show you what we're going to do. There is a table. You possibly have seen the pattern now, right? We're headed towards a table. It's on page 172. That gives you the 9 steps of a non-standard problem. You see now why there has to be an open book notes on this test, right? Because once you know what kind of problem you got, you're going to flip to this table, right? For minimum problems, or for maximum problems, or for non-standard problems, or whatever. Okay, so what did you? 172. 172. Alright, so how do we decide what we're going to pivot on? Well, what we do is we pick the row that had that negative value in it that was the problem. The one that comes from, okay, this was the variable that had the problem, S3, so this is his negative value that's the problem. There could be other negative values elsewhere, especially the non-basic variables, but we don't care about that. This is the guy who's causing our problems. So pick his row. I'm not saying the pivot's in this row. I'm saying this is the row we're noticing right now. We're noting this row. And what we're going to do is you're going to pick the leftmost positive value. Again, this is explained in the table. In that blue box or yellow box or green box, whatever that thing in color is in your book. And we're going to pick the leftmost value that's positive. In this case, it's the one I have highlighted in yellow. That is not the pivot, but that will be the column of the pivot. So your pivot is going to be in there someplace. Now, just like before, what we're going to do is figure out the quotients. I'm going to start using the correct vocabulary word, just so that we have that jargon. The correct expression is you investigate the quotients. I don't really know why the word is investigate, but what you do is you compute the quotients based on the rightmost column divided by the column that you picked over here. I don't know why the verb is investigate. Okay, so let's investigate the quotients. 100 divided by 1 is 100. 500 divided by 10 is 50. 60 divided by 1 is 60. We've got our quotients. Just like before, we throw out any of them where we divided by 0. We throw out any of them where the denominator was negative, but that didn't happen this time. So we just picked the smallest one. And the smallest one is the one I highlighted right there. So that's the row with the pivot. So now we know the row with the pivot and the column with the pivot. So we have the pivot. Again, I get it that there's a lot of little steps here. That's what you need for the book. Maybe that table isn't useful to you. People learn different ways. Maybe you want a flow chart. Maybe you want some kind of workflow diagram. Maybe you just want your own notes. Maybe you've got some way of writing that makes sense in your mind. Okay? Maybe you're some kind of sensory learner and something else makes sense to you. Okay? Knock yourself out. If you have a different way of wanting to express this, I am totally supportive of that. MJ, how supportive of that should I be?
100%.
Like extra credit supportive of it? Like if you want to put together your own way of understanding these table and the other ones we've seen, and I should give you extra credit for that? Like if people wanted to draw out a different way of seeing it or express it what worked for them?
I mean, you could.
I think I might. I don't have a plan. I've done that in classes before though, where if you have a way that will help you understand things, and you drew a flow chart or something like that, send it to me, scan it to me, take a picture of it, whatever. I'm supportive of that. I can find ways to put extra credit or something on there. Does that make sense?
Can you do that in pre-calc?
I don't know that there's anything in pre-calc to do that with. Go do that damn rocket problem instead. Alright. Pre-calc has a rocket problem they're working on. They're doing the trajectory of the Mercury Redstone rocket or something like that.
I think it was the Freedom 7.
Freedom 7, that's right. And they're unhappy with it.
I looked at it.
It's lovely. Alright, let's just do the pivot. Alright, I love these pivot slides. Alright, first things first, it always just makes sense. Copy the pivot row. I'll take it back. Sometimes that makes sense to do first. On a spreadsheet, I don't usually do it first, just because I get confused as which row is which then. So I usually just start at the top. Alright, on a PowerPoint, it's no big deal. It makes no difference one way or the other how I do it. Alright, now, let me back it up here. How are we going to get rid of that one? Okay, so remember, pivoting, let's just kind of use this as a review. How are we going to get rid of this one up here?
10 times row 1 minus row 2.
Yep, you always want to do it, the row you're talking about, and then some operation on it compared to the row of the pivot. So, 10 times row 1 minus row 2 sounds happy to me. Let me see if that's what we did. 10 times row 1 minus row 2 becomes the new row 1. That makes me happy. I don't see any negative number over there in the rightmost column, so I think we're okay. What are we going to do about the third row?
10 row 3 minus row 2.
10 row 3 minus row 2 is going to be row 3. Yep. Alrighty then. Oh, happy day?
Slow down, please.
What did you say?
Slow down.
Okay. And again, I'll put this PowerPoint up for you, if it isn't already on It's Learning. I made all these PowerPoints in advance in case I was in jury duty. And so I have to admit I don't remember what, and then I put them on It's Learning with a timer or whatever, like they open up as we go through each one. And so I don't happen to remember if I've got them all posted or not. Okay. What about that bottom one? How are you going to clear out row 4?
Row 4 plus 12, row 2.
I think row 4 plus 12, row 2, because again, we want to take the row we're talking about and somehow relate it back to the pivot row. Let's see if row 4 plus row 12 is what I did. Yep. I'd say, is that what I did? Because of course there always are other options. In fact, there's an infinite number of options on how to do this. We could have said, 1/12 of row 4 plus row 2. It's just that those kind of things get harder, right? I mean, it usually just makes sense to compare them directly, just use the coefficients of one on the other one, it works best. All right, so we have this here. It's a solution. Now, remember, before we had a problem of, yeah, there's a solution, it just isn't feasible. So I feel a little once bitten, twice shy. You know that expression? The first time you went and you pet the cat, it bit you. Now go pet the cat again. Right? Once bitten, twice shy. This thing bit me once. Let's see if it's the right thing. All right, we've got to find our basic variables. All right, no problem there. I see them. Okay, so the other ones are non-basic. So the other ones are saying x1 and x2 are 0, for that matter, so it's the second slack variable. And then we should be able to pick off the values of x1, x2, and x3. I mean x1 and then the other two, the slack and the surplus variable. And I get that the slack variable is, I'm sorry, x1 is 50, slack is 50, and crap. Do you see some problems here?
Yes.
Yeah, we still have a negative value of one of the variables. And actually, when you take a look at this isn't even a feasible solution, is it? I mean, I'm only planting 50 acres altogether. That doesn't meet my criteria. So, we got to play the same game again. All right. So, once again, we got to apply our technique again. All right. We got to take the one that was giving us trouble here. It was S3 was the variable that was negative. And we find its negative entry and we say, this is a row that I'm interested in. It's not the row of the pivot necessarily, but it is a row I'm interested in, and I got to go and find the leftmost positive entry, which in this case is the 6. Yeah,
Okay, so whenever you say leftmost, does that mean any positive entry that's farthest to the left? Because not the most positive, right?
No, yeah.
Okay.
It's leftmost.
Okay.
Okay, why? Malia is onto something here. Malia says, why leftmost, basically, right?
I didn't know if you meant left most positive
No,
or
leftmost positive.
Okay.
Very good, that's interesting. Okay, the book actually has a footnote or a sidebar or something about this here. In this particular case, in fact, any of them would, any positive number would, any of the positive rows would work, or positive columns would work. The problem is you want to be systematic about it. That comes back from the day, well, first off, you're going to make, if you were coming up with a technique to do this, like you're making an app that helps the farmer know what to do, or whatever, you would want it to be systematic, right? We're always doing the same thing. Also, back in the days when these were done by a computer in the sense of a person who does the computing, you wanted, generally speaking, more than one person were doing it. That way they were checking their answers, right? If you used one thing and she used another, you might not end up at the same solution, right? So this way we are all doing it the same way. Okay? Well, eventually it turns out you would eventually both get to the same answer. Because there is an optimal solution, right? It's just that you might not, if you didn't come up with the same answer, then where are you going to find how you made the mistake, right? This way we have a method that is consistent. All right. So we know that our pivot is in this column. Then we go over here and investigate the quotients. Again, this time, the quotients are nothing all that tricky because there's no divided by zeros. There's no divided by negative numbers where we guys start throwing things out. All right, so we're just going to pick the smallest one. It happens to be this one. All right, so our pivot pivot is where those two intersect. It's back here on that 6. So it turned out that thing was the pivot after all, but that's purely by luck. There was no reason why that would have been the pivot. Alright, so here's the pivot. Okay. Oh, we're good at this now. Why don't we save ourselves a little time by doing the pivoting pretty fast here, right? We know we just copied that first pivot. Ah, now you guys like to write these down.
Yeah.
Yeah, you like to write things down. You know what? Row 1. To get rid of that 6, we're going to need to take row 1 minus row 3. Make sense? I'm trying to figure out if I want to be careful about something here. I know a mistake I made when I made this PowerPoint. And I had to go back and throw out a ton of slides. Like, you can imagine, Malia, how happy I was about that. Crap. It's easy to be overly excitable when you see a 0 in a row that you are already working on. I know when I made this originally, I said, oh look, row 1 already is a 0, so row 1 is just row 1. Because there are some of the tableaus, have you guys come across any of them yet? Where, you know, like if this value here was a 0, we wouldn't do anything to that row. Row 1 would just be row 1, right? That would be okay. There's no harm to that at all. It's effectively the same thing as saying row 1 minus 0 times row 3, right? Sometimes there are zeros in here. Okay? That's fine. But it's easy to like fall into a trap and be like, oh look, there's a 0 here. I'll just copy row 1. No, it's got to be in the row column of the pivot. Yeah. I made that mistake a handful of times making these PowerPoints, let me tell you. Alright.
All I can think of is you being like, math, as you're typing up these PowerPoints. And then
I am so exactly like that. Dude, you're in my, I'm in your head now. Alright. Mostly yelling at my kids while I was doing it, because it was a Saturday morning. I remember that. My wife was at she was some kind of exercise class, and kids were watching TV and fighting, and I'm trying to make PowerPoints. Alright, row 3, you know how to do this. I'm sorry, row 2 rather. This one was a little bit messier, because I had to go to a common factor, a common multiple rather. But I mean, it's a thing. Alright. To be honest, I would have, okay, I could do, when I was doing row 2, I would have said 6 times row 2 plus 4 times row 3, but it works this way too, and that's in fact how the book did it, so I did that one. Alright, because I had already been burned, because I already made the slides wrong one time, so that would do it exactly the way the book did. And finally row 4, same sort of thing. I had to get myself to a common multiple. The least common multiple, strictly speaking.
This is my least favorite part of doing these.
Is it?
It's like everything.
Oh, okay.
I hate it.
I agree. I'm always spooked by this number down here, because it gets big.
So error prone.
Yeah, I agree. But once you got it. Can we read a solution off this one? Alright, we got a matrix. Where are our basic, we got a tableau, strictly speaking. Where are the basic variables? Looks like they're these 3. Yeah, I don't see negative numbers there. Alright, so, x3 is equal to s2 is equal to s3, which is equal to 0, because they're non-basic. And we can do the math, and those are numbers, and it's fine. I didn't actually do the math as to what they are, but it adds up to more than 60. Someplace I have it. Alright, it's a feasible solution. It's more than 60. We have no slack variables that are positive. I'm sorry, that are negative rather. This is a feasible solution. Doesn't mean it's the best one. We have not yet necessarily optimized his, what was it? Profits, I think was what he was going for. Okay.
So this whole thing was just to make it...
Just to get it back into feasible.
Okay.
Yes. We got back into feasible. Alright. Now, in this particular case, we would use the simplex method now to just go forward like normal. In this particular case, we only have positive values down there in the indicator variables. So in this particular case, we already have the optimal solution. Now, they kind of played a little game with you. How do you think he really did this? He actually reverse engineered this, right? He figured you had just been through all this business of first getting it pivot to get it to even be optimal. He wanted you to stop at that point and you have the solution already, right? But I mean, that's kind of fakey, right? He engineered the problem to work this way. That's part of the trick of what he did with those least common multiples and stuff like that in there, okay? To get himself to this way. But you can see we actually have the optimal solution here, which means, because there's no negative indicator variables or anything, means we can start picking off our answer here. We wrote the problem out mathematically like this, and we end up with x2 is equal to this, x3 is equal to this, or whatever, and it works out to 43 acres of potatoes and 16 acres of corn and no acres of cabbage. Wait a minute. Does that seem surprising to you? How many acres altogether is he planting? 60. Yeah. I thought that was a surprising answer. You would think he'd maximize his profits by planting even more. But apparently, the more stuff he plants, he's just not making any more money. I don't know. I'm surprised. Yeah, that sounds regular farming, by the way. It's in many ways better to just not plant. Okay. But anyway. But it can be surprising. It can be surprising that sometimes the solution is don't put more stuff on the truck. You've got a bare minimum you got to put on the truck and leave the rest of the truck empty. Can be the right solution. If you're not making any money delivering those things, it could be. Don't put it. Okay? I know I was doing some problems on there. I think they might have been examples of some problems that we're doing on Monday. Where it was something about tomatoes. They had a whole bunch of tomatoes. They were trying to figure out how much sauce and how much tomato paste or something to make at a factory. And it turned out they lost money on one and they make money on the other. It makes sense to make all of it the stuff that you make money on and let the competition make the stuff that you lose money on, right? There's still got to be tomato paste on the shelves, but let the competition make that stuff. They're losing money then, and you're making money. It was smart. So anyway, this is literally just cut and paste the stuff. These are exactly your steps on page 172. The exact steps we just illustrated greatly. So, I mean, I don't think we need to have this like here. I didn't make it like that other time where we kind of piece through it one step at a time. What I want you to illustrate then is, I think it makes more sense for us to do another example. Now, to save time on the second example, I'm not doing a story problem. Okay, we're just taking one of the ones where it's already written out in mathematical form. Instead of talking about how many cans of tomato sauce and how many cans of tomato paste or something like that. All right. Right off the bat, I can see that this is some kind of weird non-standard problem because it's got some subject to constraint that is a less than and some that is greater than. So there's going to be a slack variable and a surplus variable. I'm a little spooked by that minimize thing, though. So wait a minute here. Am I going to be figuring a dual problem while I'm at it and so on? Well, this kind of spooked me a little bit. Because the book said, wait a minute. You're kind of doubling up on your work then. If you first get this whole damn thing written out, and then you figure the dual problem, and then you solve the damn dual problem, why not just change this thing right over here, right from the start, into a maximization problem? They said, if W is equal to this, and you're trying to minimize it, well, hold on. Change the book. Actually, again, it's so dense. I picked out a sentence here that's important. Just change this into a maximization problem by saying Z equals negative W. If you're trying to minimize W, that's the same thing as maximizing negative W. Right? And so we can just flip this thing into a maximization problem by doing that. So if W is equal to 3y1 plus 2y2, just make it negative W equals negative, it's fine.
It is fine.
It is fine. Now, it is very easy to lose faith at that point and say, well, what the hell did we do in section 4.3 then?
That's what I want to know.
Good. You've asked a great question that I just planted there. Wait a minute, if we could just flip those damn things and make it z equals negative w, why did we go through all that before? Because back then, all these inequalities were the other way around. We still, even if we had flipped this into if we had just taken that z equals negative w, we still would have had the problem that these were all greater thans. It still wouldn't have been a maximization problem. Right? So that didn't solve our problem there.
Wait, I'm confused.
Okay, back. Maybe that's a good time to write something on the board. All right. Last section. We had problems that were something like w equals 2x, let's use y1 plus y2, and we were trying to minimize this, subject to, and we had constraints like 2y1 plus 3y2 is greater than or equal to 6, and y1 plus y2 was greater than or equal to 2, or something like that, right? And we went through all that stuff about dual problems to change this into a maximization problem. Well, now we're saying, instead, for these non-standard problems, just say, you know what, z is equal to negative w. I just flip this thing.
Okay, but what are we doing?
But yes, and you might say, why didn't we do that last time? Because these would still be then pointing the wrong way.
So then,
So like now, so we're changing it into like a maximization, right now.
Right.
On the thing, we're turning it into a
Right,
maximization problem.
right. Because we're going to be putting those slack variables and surplus variables in.
Okay.
And it's going to, see, we didn't have all that surplus variables and stuff like that last time, right? Okay, so here's the deal.
so now we don't even look at 4.3, I'm guessing.
4.3 is only for standard minimization problems. This is not a standard minimization problem. It can't be written by that stuff that we had
Then
at the...
how do you
Because
know?
when we,
How do we know if it's standard or not?
It's a standard minimization problem if it's minimizing some objective function and all of these inequalities are this way. They're all greater thans.
Okay.
Okay? If it's a mix,
So
we
that-
can't do
wait,
that.
is that-
There isn't a dual for this problem yet. Okay? So when we get into this form here where we got some that are less thans and some that are greater thans, this trick of the duals doesn't work. But instead, we can just say, look, if I just flipped this minimize w into a maximize z by making z equals negative w, then it's just a regular non-standard problem that's got surplus variables in it. Here's the deal. My guess is the standard minimum problems, we could do this too if instead we just added a surplus variable here and here, every one of these things, instead of making a dual problem and then adding slack.
that's a lot of work.
Yes, I think that would just be so many more steps.
'Cause then,
But my guess is you'd come to the same answer.
yeah, because then if you had like surplus variables, wouldn't you have to do the thing?
First you gotta do all those pivots to get rid of those surplus variables to get back into feasible variables. So,
if it's,
yeah, go ahead.
I'm so confused.
Oh, don't be confused. Let's figure this out. We got time.
Okay, in non-standard, I'm confused. What do you do with so whenever it's non-standard, we do what we just did.
Yes, non-standard means that you're going to have slack variables and surplus variables in there.
Okay,
And we got all these damn pivots that we got to do before we even get to feasible solutions.
Okay, but if it's standard minimization, we do what
We do the duality thing, where we do the thing where we transpose it and we get the corresponding maximization problem. That's what we did last time. Last time we took a standard min problem, where we were minimizing an objective function subject to all these constraints that were greater thans.
It's when, like,
And
signs-
the path of least resistance was to do the dual by doing that thing where we transposed it, which changes a minimization problem into a maximization problem. And now we're pretty damn good at those max problems, right? Now we're saying we got a mix of these things. Some are less thans and some are greater thans. We're going to do this thing instead with surplus variables. But that does mean that we got to go through this heavy lifting of getting it back into feasible solutions by doing all those pivots first. Okay? I'd be glad to talk more about that. Okay? I want to make sure that we're all clear. But because I agree, I think it's a little bit scary. Okay? We have a third method that kind of feels at first like it undermines what we learned last time. What we learned last time was purely taking a standard min problem and using the property of dualities to turn a standard min problem into a standard max problem. Now what we're doing is we've got a non-standard problem where we got a mix of greater thans and less thans, and we're going to play a different trick. We're instead going to change the min, if there is a minimum up here, change it into a max by making z equals negative w. That way, we can just do the thing with surplus variables and it's fine. Yes?
Okay, this is for
Yeah,
a
yeah.
standard one. But like, whenever we're doing the transposing, do we really have to do the matrix to transpose it? Or
I would, just to be sure I wasn't making a mess of the whole thing.
Okay.
Trying to do it in your head, or trying to do it like, oh, I'm just going to copy these numbers. I agree. When you pick them off there, you could probably, instead of writing them in rows, write them in the columns and you'd be done.
Yeah.
Yeah. If you could do it without getting tracked, I'm not going to count off that you didn't do it.
Okay.
But I think it's so error prone. I think I'd be scared I'd make a mistake. Okay, but it's up to you. Okay.
No, because I was just asking because like it's easy if you line up all just the problems and then you like.
Yeah, you just pick them off there and go by columns instead. Yeah, I agree. It would be, you certainly can do it.
Okay.
I'd be a little scared, but I mean, whatever. That tends to be me. So here's what we did. We took that same problem that used to say minimize me, W equals this, and said, you know what? Maximize the opposite of it. Maximize negative y1 minus y2. Because just playing that little game changed it into a non-standard problem of looking for the max, and that's something we know how to do now in section 4.4. It's going to be at first a non-feasible solution, and then we got to pivot and all that kind of crap, but we know how to do that. All right, subject to these constraints. All right, so we're going to add our slack variables and subtract our surplus variables as needed. And so we will go and change those inequalities into equations. Instead of y1 plus 3y2 is less than 6, let's make y1 plus 3y2 is adding a little slack to it, and now it is equal to 6. And instead of 2y1 plus y2 is greater than 3, let's make that a surplus variable thing. 2y1 plus y2 minus a little extra that you had gets you back down to 3. Okay. Now you got to do something with that objective function. We pull everything over there to the z side. Hey, that doesn't look familiar. We've never had one before where when we pulled everything over here to the other side, they weren't negative numbers. But that's okay. It just never happened before on our problems. Okay, but it's okay. That's not going to hurt anything. So we put this together into an initial tableau, which we're good at. And to quote our section, our table or whatever on page 172 that has, or 174, whatever it is, that is where this comes from. Step 4 was any basic variable has a non-negative value. We look for that. Okay. So here's our basic variables. Sure enough, one of them is going to end up being negative. That's going to be the problem. See, this is the coefficient. That's the problem. We're going to end up with we're going to end up with negative 1 S2 is equal to 3, which means S2 is negative 3.
Wait, I'm confused. Go back.
Yep. Those are our basic variables.
Go back again.
Yep.
I do have a question, just like when reading it off. So if you have like the slack variable, when you read off the solution, if there happens to be a solution, would it become like a negative, or I'm just
Right now?
no, like so if you solve it and like the surplus variable happens to be like a basic variable, would it be like become a negative, or would it just be like that answer?
Right now, this surplus variable is negative.
No, but like whenever you solve, like if you get it and you like solve it, but there happens to be like the surplus thing is a value, and it's like now positive. When you read this,
It's not a feasible solution then. But yes,
Okay.
so you'd write it down. It's a solution, but it's not a feasible solution, right? There's no feasible way to get to that,
Okay.
right? If the surplus variable is negative, remember that means that like your acres of corn plus your acres of cabbage plus your acres of potatoes is less than 60, right? Because you were subtracting a negative surplus, but see, you haven't met your contract yet, so you haven't yet got to feasible solutions if the surplus variable is negative. Okay. All right. So here's our simplex tableau, and we find our basic variables. We can see that we got S1 is equal to 6, and S2 is negative 3, and that's not good. That's not feasible. So we got to take that negative surplus variable, and we got to go through the procedure that we learned on page 172 or whatever, where we say we're going to think about this row. That doesn't mean the pivots in this row. It might be, but that's not the point. We go and we find the leftmost positive value. And according to the algorithm that we learned on that page, that means that one of these in the column there is going to be our pivot. And we investigate the quotients by taking the rightmost column divided by the column in question, and we get the quotients, and clearly one of them is, none of them were divided by 0, none of them were any of the other things dividing by a negative number or anything like that. So far so good. And we get our quotient is 1.5, that's going to be our smallest one. So we now know where our pivot is. Alright, we can do this. We know now how to pivot. We take the same damn thing. And I'm going to skip the math here because I don't want, we're running out of time. So I'm going to skip all the math. We know how to pivot. And we got to our final tableau. We got a tableau. Well, not our final tableau. Our next tableau. Let's take a look here. Those are our basic variables. Everything else is non-basic. It's equal to 0. So these guys are positive. They're not negative. So this is at least a feasible solution. Now in this particular case, well, let's first convince ourselves that it's a feasible solution. We can put y1 into here, and y2 is equal to 0. And you could convince yourself, I'll let you do that on your own, that that makes this less than 6. It means y1 plus this times 0. It's going to be less than 6. And you could convince yourself that 2 times this number here, which will be 3, plus 0 is greater than or equal to 3. It worked. Okay?
Wait, okay, can you
Yeah, I know we're moving a little faster toward the end. I apologize. But I mean, you can go back to your original slide and prove yourself that this is at least feasible. Which makes sense because all our slack and everything like that is 0 or greater. So not negative. Our slack and our surplus. It would work. Now, in this particular case, we look for any non-negative indicator variables, and that's our next step. And in fact, this time there aren't any. So again, the guy who actually engineered the problem so that, we didn't have to do more stuff. Because he knows you already know how to do these kind of problems. I mean, if there had been a negative variable, you know how to do all the regular pivots and all that kind of good stuff. So in this case, this is the solution. And the non-basic variables are S1 and Y2. I'm sorry, S2 and Y2, so they're both 0. And the basic variables are Y1 and S1, and so Y1 is 3/2 rather, whatever. And that gives you Z is equal to, we can pick Z off of here. Okay, 2Z equals -9, so Z equals -9/2. By the way, notice it's not a problem that this is a negative here. We worry about negatives in the rightmost column. I don't have an answer as to why it can be, the Z one can be, but that's...
It's because it's special.
It's because it's special, let's say that. Good enough. The other ones you would not want. Alright, so I agree, this should have set our alarms off that it did, which means W in this case would be 9/2, and that is in fact what the answer in the back of the book is. Alright.
Wait, can you go back?
Yeah. Okay.
There's more.
No, well, yeah, that's half of section 4.4. Okay. So, here's the deal. Well, this is a solution to this problem. But I agree. I think the non-standard ones are scary. but they're also kind of the most general ones, right? I think when I think about the kind of things a business has to be making decisions about, this gets to be the most. Now what I want you to do, so yes, we have one more day about this stuff called artificial variables, but that's another story. In the meantime though, you want to write down the assignment, which is not very many problems. Just write them down though. Because I also want you to do an exit ticket. It's already posted for you. And it's mostly about interpreting a problem. Alright, I'm going to stop the camera and I'm going to quickly, while you guys start working on that exit ticket, I'm going to carry the camera upstairs just so I have one less thing to carry.